Hi everyone, my name is Preshayla and today we're going to be going through an example question based on the AQA exam board for GCSE Physics. This question is all about forces in motion and more specifically distance time graphs. So it's important that we know each of the features of a distance time graph, which is what this question asks us. What does each section of the graph represent? Part A of the graph shows an increasing gradient. This means that there is acceleration in this part of the graph. Then we have a straight line, so a straight line portion of the graph represents a constant speed. The speed is not changing, the object moves at the same speed for that period of time. In section C, we can see a decreasing gradient, so it goes from a steep gradient to a shallower gradient, which means that there is deceleration happening in that section. And then in section D, it's a flat line, which means there is rest going on. The object has come to a stationary motion. Okay, so the next part of the question asks, how do we measure the instantaneous speed when an object is accelerating? Well, the accelerating portion of the graph can either be known as this point here and this point here. It's not always necessary to clarify whether accelerating actually means getting slower or getting faster. Accelerating just means that there is a change in speed. So let's take this portion of the graph here, portion C from the previous part of the question. We know that the speed is getting slower, but we want to find the instantaneous speed when the object is doing this acceleration. So we want to know the speed at this point here. Well, we know that to find the speed from a distance time graph, we have to find the gradient of the graph. It's much easier for a straight line graph, but our accelerating portion of the graph is a curved graph. Therefore, we need to use a different technique. The technique that we use is to draw a tangent, which is a straight line that touches the curve at a point and carries on. So you can see that the tangent touches the curve at a point and carries on either way. That's called a tangent. Now we can find the tangent gradient. It's a good acceleration for the curve. Not perfect, but it's good. So we're going to find the gradient of the tangent. Now we find the gradient of a tangent how we normally do, finding a gradient of a straight line, which is the change in y over the change in x. So for the gradient of this tangent, we would do the change in y, which is this distance here to here, over the change in x, which is this distance here to here. So to find the gradient of an accelerating portion of the graph, whether it be actual acceleration or deceleration, we draw a tangent to the graph at the point where we are trying to measure the instantaneous speed, and then we measure the gradient of that tangent.